you will have an IP of the same range usually, right? Because usually you will be getting an IP from the same provider, so it's easy to maintain, right? So you will have to pay for getting a public IP. You will have to pay per each IP, right? Or you might you can get a IP block. That means 2 or 3 or 4 IP addresses, right? Anyway, you have to pay. If you are getting more than one IP, also you have to pay more, right? So this is IP-based virtual multi-hosting. So one IP per domain, right? So per each domain you have a separate IP, right? Then whatever the traffic to this domain, uh, so you have to have more than one network card. Obviously, you can see, right? You cannot assign 2 IP addresses to the same network card or port, right? So you have to have multiple network cards or ports available in the server, right? Because we are having this in the same server. So traffic will be directed to the relevant port or card, network card, right? So traffic of abc.com will be forwarded to this IP's port. Then traffic of this domain will be forwarded to this IP's port, right? So that is one way. Then name-based virtual multi-hosting. So this is a feature of the web server, right? So you can configure actually. So let's say these two will have the same IP, this one, and then based on the name, right. So same IP file location is identified by name, right? So as I showed you earlier in that image where I showed you the folders, right? So inside the htdocs, you will have separate folders for both of these domains, right? So let's see, yeah, for this one you have a folder called ABC, uh, so which should be inside htdocs, right? So I'm talking about Apache server, right? IIS, the location is different. So this will be so for this domain, and for the other domain, so then there will be another folder. Right. And how it is directed to the correct folder is, so you only type this, right? abc.com or pqr.com. You don't type slash something, right? So this domain is actually uh, referenced to the relevant folder, this abc.com. So this is referred to this one, and this is referred to this one, right? So if someone types abc.com from outside, right, now both are having the same IP. So all requests will come to the same IP, right? So now how to identify where to send the traffic, this one or this one? How? So that will be done based on this name, right? So if someone types abc.com, so it will come to this IP, the request, right? So the web server will check the name, what is the URL or request from the client. So if it is ab.com, then it will be directed to this folder, right? So this page will be sent again to the client, right, which will display in the browser. So if the client typed this or requested this URL, right, pqr.com, so again it will come to the same IP, right? So when it comes inside the server checks what is the name. Okay, pqr.com. So it will redirect the traffic to this folder. Then this folder will be sent back to the client, right, as a reply. So this is done by the web server, right? So that is called name-based virtual multi-hosting, right? So earlier we talked about IP-based virtual multi-hosting. So we have to have a separate IP per domain, right? Then we have to actually pay more for that, right? So those are two methods. Then port-based, same IP but on different ports. So yeah, so it will be like this. So same IP, then how it identifies is, see, I told you now normally HTTP traffic is coming from 80 port, right? So you can change the port to something else, right? So for example, now if I use this port for this, right, then it will go to one folder, access one folder, right? And then for the other one, I can use another port. So then it will, check the port and then direct the traffic. Right, so different ports. You have to actually type the port here, because if it is not the if it is not the default port, you have to type the port actually, right? Otherwise, so these are the three methods how you can host websites, right? Especially in the same server. If you are having multiple domains in the same or multiple websites in the same server, right? Yeah, so having like this in the same server means the same bandwidth is shared, right? So if you get a lot of requests from customers or clients, um, so it might get slow, the server, right? According to the network or internet bandwidth, the package you have, right? So in a server, it's not like if you host a website at home, right? So one thing is you definitely would need a private IP, right? Sorry, public IP, right, for the website, because otherwise no one will be able to access your website, right, unless you have a public IP. Then the other thing is for others to access this page, right? So this page will be sent to the client. So that will actually be a upload, right, not download. So if you are using a ADSL connection, so usually the upload speed is quite low, or it's very slow, right? So that is not suitable for having a web server or hosting a website, right? So there should be the upload speed should be higher, right? Otherwise, people will not be able to access the web page, especially if you have a lot of images, videos, and things like that, right? If you have a simple web page like text, um, yeah, if it is like text based mostly, then you might not have that much of a problem. But if you are getting a lot of requests from a lot of people, right, because anyone can access that website, right? So anyone, let's say typing abc.com or pqr.com, will come to your server, right? So when the request increase, then you have to have enough internet bandwidth, the package, for the people to actually see your page, right? So yeah, so then ADSL is not suitable for hosting a web page, right? Then you might have to upgrade to a better package. So especially the upload speed should be enough, right, for people to access your web page. Otherwise, it will be quite slow. So it will be a download for the clients, but it will be upload for the server, right? Because server is sending and the client is receiving. Right. Right. So I hope that is clear. Any questions regarding this?
clear sir.
Okay.
සර් එතකොට දැන් ඔය මේ එක සර්වරේ දැන් ඔය සර්වර් එකේ දැන් ඔය වෙබ් පිටු දෙකක් දානවා නම් එතකොට NIC දෙකක් දාලා NIC දෙකටම IPs දෙකක් දාලා තියෙනවා.
ඒ එක ක්‍රමයක් විතරයි.
එතකොට මේකෙදී මේ
IP based. ඒ IP based. එතකොට වෙනම network card දෙකක් ඕන. මේකේ මේ දෙකට ඕන නැහැ. මේ දෙකට මේ තියෙන same IP.
ඒකේ port එකෙන් තමයි වෙනස් කරන්නේ.
ඔව් same IP කියන්නේ same port. එතකොට වෙති bandwidth එක share වෙනවා. Right? ඒ කියන්නේ people who will be accessing both these domains request will be coming through one port. That means one network card. So that should be a good network card, right? Even if you have a good internet package, the network card also should be a good one, which can handle the traffic, right? Because you have everything is coming through one network card.
Okay sir.
So, yes.
සහනද
Yes, I know.
එතකොට IPv6 වලට ඔය concept එක ගෙනහම කොහේ
IPv6 එකකට දාන්න පුළුවන්, no issue.
අර
IPv6 දානවා කියන්නේ එතකොට IPv6 support කරන්න ඕනේ. Right? So if you are
IPv6 වල අර net concept එක නැති නිසා අර MAC address එක use කරලා නේ generate කරන්නේ. එතකොට මේ ඔහොම එකම interface එකේ දෙකක් දාන්න පුළුවන්.
usually එකම interface එකේ දෙකක්. ඔව් එතකොට Mac එක use කරලා හින්දා usually standard විදිහට දානවා නම් එකයි දාන්න පුළුවන්.
අර මේ අපිට තියෙන IPv4 එකේ limitation හින්දා මේක දාන්නේ. අර IPv6 එකේ එහෙම limitation නැහැ.
ඔව් IPv6 එකේ limitation කියන්නේ ඒකේ ගොඩක් devices වලට IPv6 දෙන්න පුළුවන්. Right, because they are 128 bit නේ, so users ලා ගාන or devices ගාන බැලුවොත් ඕන තරම් දෙන්න තියෙනවා. It's not limited, right? ඒකේ වෙනස තියෙන්නේ basically ඒක තමයි තියෙන්නේ වෙනස. ඒ කියන්නේ ගොඩක් devices වලට දෙන්න පුළුවන්. But basically ඉතින් එක device එකකට එක IP එකක් තමයි allocate කරන්න පුළුවන්. Multiple IPs allocate කරන්න
එතකොට සර් මේ concept එක ඕනේ නෑනේ IPv6 වල. මේ අර MAC address එකේ අර IPv6 address එක generate කරගන්න.
ඔව් ඒක එක ක්‍රමයක් විතරයි. ඒක තමයි සාමාන්‍යයෙන් use කරන ක්‍රමය. MAC address එක base කරලා කරන්නේ. Then it will be unique. Right, if you base the IP on the MAC address, then that will be unique. That is why the MAC address is used, and it's easy to generate. That is why it is used, but that is that is the standard mostly used. But වෙන මොකක් හරි standard එකක් use කරන්නත් පුළුවන්. But that is mostly the standard used in IPv6. But everyone has not moved to IPv6 yet, right? I think IPv6 විතරක් තියෙන මේවා අඩුයි. ගොඩක් වෙලාවට දෙකම තියෙන එහෙම තමයි තියෙන්නේ. IPv6 IPv4 දෙකම තියෙන විදිහට තමයි තියෙන්නේ. මොකද IPv6 විතරක් කරනවා කියන්නේ එතකොට customer base එකත් අඩු වෙනවා. IPv6 විතරක් support කරන අයට විතරයි access කරන්න පුළුවන් වෙන්නේ. So usually you have both IPv4 and IPv6 if you are having a web server. Then both people who are having IPv4 and IPv6 can access. IPv6 is now ඒක දැන් ටික ටික එනවා. And lots of devices are new devices support even your phones, right? New phones support IPv6. But you know these internet providers, they have, I think, not moved only to IPv6. එහෙම නෑ. දෙකම පාවිච්චි වෙනවා. But IPv4 තමයි ගොඩක් දුරට use කරන්නේ දැනට. එහෙම ලොකුවට IPv6 වලට කළා නැහැ. Right, but usually per interface you can use one IP at a time, right? Even if you assign yeah, you can assign two IPs. In Windows you can give an alternate IP. That setting is there, but that both IPs will not be used at the same time, right? In Windows actually you can put two IPs. That is, you have to put automatic, and then you can have an alternate IP set also. If the automatic is not working, then it will automatically assign the alternate IP which you have given, right? If you have not put an alternate IP, then බලන්න ඕගොල්ලන්ගේ ගොඩක් වෙලාවට network එක disconnect කරාම මොකක් හරි IP එකක් තියෙනවා. ඔයගොල්ලෝ IP config ගහලා බැලුවොත් so that is by default. Some IP will be assigned even if you don't have any IPs available, right? If you connect to a network and let's say the DHCP is not working, so then automatically a private IP will be applied to your network card or device, right? You can check that. How can you check that? Right, you can check it like this. Network port, network cable එක ගැලවුවොත් කොහොමදත් IP එකක් තියෙන්නේ නැහැ because it's disconnected. So your network, that port should be connected, then you have to disconnect the DHCP from it, right? එතකොට මෙහෙම කරන්න පුළුවන්. router එක ඔයගොල්ලන්ගේ router එකට කෙලින්ම ගහන්න නැතුව computer කෙලින්ම ගහන්න නැතුව connect කරන්න through a switch, right? Connect your computer laptop by cable to a switch, and then connect the switch to the router, right? Then disconnect the switch from the router and see, right? First connect to the router and see that you will get a automatically IP from the router, right? 192.168 something. Then disconnect your switch from the router. So when you disconnect, so you won't get IP from the router, right? DHCP. Then automatically a private IP will be assigned to your computer. I think 168 or something like that. So you can check that way. If you disconnect from the cable from your computer or laptop, then because network is disconnected, there will be no IP given or applied to your network card, right? So your network should be connected. Then if you disconnect your DHCP and see, you will have some other private IP address assigned automatically, right? It's there in Windows 10. Right, so you can check that in the way I explained, right? So so that is, you know, you can assign two IPs to the same card, but both won't work at the same time, right? එකක් නැත්තම් තමයි අනිත් එක use වෙන්නේ. Because if you have two IPs to the same network card, then that will be a problem, right? How is the switch? How does it identify the which traffic to send and all that? So it will be complex. So so usually you can assign only one IP at a time, right? Okay, so let's move on to the next. Okay, so yeah, reverse proxy. So I think you know about the proxy server, right?
No, sir.
Proxy server, didn't I explain to you earlier?
No, sir. Proxy are going to explain, but firewall is explain.
Ah, okay, right. Okay, so this is right. Then I think I should explain about the proxy first. This reverse proxy is a different thing. Yeah. Wait, let me show you in a web page. So the proxy server, also called the forward proxy, right? So a forward proxy, so often called a proxy server or web proxy. So that actually connects. Let's say you are using internet in your university, right? Then you will be needing a proxy server to connect to the internet, right? Because you are in a private network. So the computers in the lab will be in a private network and the internet in a public network, right? So you cannot directly access the public network unless it should be through a router, right? So this proxy server is usually used in the universities, right? So it will communicate with the lab computers or internal computers or LAN and the internet, right? So this will actually forward all your queries or whatever to the internet and then send the replies to you, right? That is one function of the proxy server, and the other is it will actually have a temporary cache of whatever the pages which are accessed frequently, right? If let's say yahoo.com, a lot of people are accessing that page, it will actually temporarily store the images, videos, things like that in the server, right? So when a person accesses the first time, so okay, let's say yeah, here you have the proxy server, here is the client, and then yeah, here is the internet, and then you have, let's say, the web server. Let's say the server you are accessing is Yahoo web page. So this is the client, lab PC. So this will be so this can actually work as a router also, right? The proxy server. So yeah, so this is the WAN side, and this is the LAN or local area network. This is the wide area network, right? So proxy can act as a router as well. So it connects two different networks, the LAN and the WAN, private and public, right? So right, so let's say you type www.yahoo.com in your browser. So then it will be sent, that request will be sent to the proxy server, then the proxy server will forward it to the internet, right? So you cannot directly communicate to the internet because, as you can see here, two different networks, right? So definitely there should be routing, right? Maybe, yeah, there might be a router or the proxy server can act as a router. So you will send all the yeah, forward it to the proxy server. So actually in your browser, you will have to put the setting for the proxy server, right? So only if you put the setting in the browser, when you type something in the browser, it will forward to the proxy server, right? Then the proxy server will forward that to the relevant website, and then so you will get a reply, right? So then this will send the request here, proxy server, then it will through the internet, it will go to the relevant web server, right? Okay. Right. Then the server will reply. Right. So through the internet, that will come to the proxy server. Then proxy server will send the reply to the client. So this is usually how it happens. Right now, this Yahoo page can see only the proxy server. Right. So externally, whatever is in the internet, it can only see public IPs, right? Because so internet is made up of public IPs. So routing happens only between those public IPs. So it can only see devices which are having public IPs, right? Private IPs are not visible in the internet. So proxy server actually hides this side of the network, right? So the internet or any server or anyone in the internet can only see the proxy server, right? So all the computers in the LAN will be behind the proxy server. So it's like a firewall, right? So because these cannot be seen to the internet, it is hidden, right? And the proxy server is the one forwarding the packets, right? So even though you send a packet, right? So this packet contains, the source destination IP will be a private IP here, right? So source destination IP will be, let's say something like this. So when the proxy server sends it to the internet, then this will be changed, right? So actually it will be the IP of the proxy server, the public IP, right? Yeah. So the packet when proxy server sends through the internet, the source IP will be changed to the public IP of the proxy server. So this is what is seen by the other side in the internet, right? So this server will reply to this source IP which is given in the packets, request packet, right? So to the internet, it looks as if it's communicating with the proxy server only, right? It cannot see any of these. So if any number of clients who send this kind of request to the proxy server will send the packet outside with the IP of the proxy server. So all will look the same to the outside. So it cannot identify that, there are actually 2 or 3 people who are actually communicating, right? So it will think the same person is communicating. So, sometimes there might be problems like, when you are like, creating this Gmail, new Gmails, right? So then when, several people might create new Gmails, right? But then Google may think, okay, the same person is trying to create a lot of Gmails, right? And then so Gmail will actually block right? If there are a lot of requests coming from the same IP. So those sort of issues are there, right? Because the internet, it sees like one person is communicating, right? Although there can be a lot of people here, right? Communicating. So there are limitations like that. Even let's say you are downloading from some, free hosting or whatever. If they have put limitations to the number of downloads per IP, right? Then if let's say 2, 3, or 5 people download from here inside, so that actually the download that website will think, okay, because coming from the same IP, so same person is trying to download, and then so it will actually restrict, right? So if let's say 2, 3 people download, then that download site will not allow. Then you will have to maybe wait for some time, maybe 1 hour, 2 hour, like that. So that sort of limitation is there, but yeah, so you cannot avoid that, because definitely here you have two types of different networks which definitely should be handled by a proxy. Right, so basically this is a proxy server or forward proxy, right? So it acts like a forwarding gateway between the LAN and the WAN, right, or the internet, the private network and the public network. And also this will, now let's say one person accesses this Yahoo page, right? So so the very first time, so it will be sent to the server, and then the page will come to the proxy server, right? So the proxy server will actually keep temporary storage of that page, right? Or cache, we call it. So in the cache, proxy server will actually keep the images or text, HTML, everything. It will be cached in the proxy server. So it will be kept for some time, that which is configured by the administrator of the proxy server, right? You can keep it for a number of days or maybe week. So that is according to the configuration. So any other person who is accessing the same page will actually get this cache copy, right? So if another, let's say this is the first client who accessed the Yahoo page, right? Then the Yahoo page, right? So if another person tries to access the same page, so this yeah, so I will have to say like this. So not first client, first Yahoo client, Yahoo page, right? The second one, so actually you don't have to again request the page from Yahoo server. You can directly, yeah, so what happens is, yeah, this will forward to the proxy server. Then the proxy server will communicate and give the page which is cached to this client, right? It doesn't need to access the internet or the Yahoo server again. So this actually will save some internet bandwidth, right? Having this caching. So even if you download Windows updates or Linux updates, right? If let's say the very first machine downloading will have to access the internet, the server, right, to download the updates. Then it will be stored in the cache, right? The second computer who will be downloading the Windows updates, or if it is the same updates and Linux updates, if they are the same ones, they can be accessed from the cache. So the cache size and those configuration should be configured by the administrator, right? So administrator can decide what is the limit of the cache size which is stored in the server. So, right. So based on the hard disk capacity, you can allocate. Right. So if you allocate a large amount for the cache, so then actually, those sort of updates and so on, they can be cached and sent directly to the clients, right? That will save internet bandwidth, right? So saving internet bandwidth means, a lot of people can do their work, right, without the internet getting slow. Especially, this Windows updates, Linux updates, right, when they are downloading. Now, if you have, hundreds of computers in labs, right, then it will be, the network traffic will be going quite up, right? Because several computers downloading updates at the same time. So that will eat up the internet bandwidth, right? So if you are having a caching like this, it will save the internet bandwidth, and also it will be the speed will be much high, because getting from the cache means this communication is happening internally, or LAN, right? Now this in the internet, definitely, when you download, it's a bit slow, but inside it's much faster, right? If you have especially gigabit speeds, right, or even 100 speeds is okay, but if you have gigabit speeds, then definitely that speed is higher, right? So this is how the proxy server or forward proxy works. Okay, is this clear? Any questions? Okay, then let's move to the reverse proxy. Right, so yeah, so that what I explained is here. When those computers make requests to sites and services on the internet, proxy server intercepts those requests and then communicates with web servers on behalf of those clients, like a middleman, right? So what I explained just now. Yeah, so this is a this is a diagram of what I just explained, right? So the clients will be communicating with the proxy server or forward proxy. Then that will be forwarding all these requests to the internet and to the servers, right? And then getting the replies back to the proxy, and then sending again to the relevant clients. So it keeps track on who is sending this packet, or this to send the proper reply, right? Because as I said, this is not just forwarding the packets. It's the proxy is actually changing some header details in the packet, and sending to the internet. So then again, when it gets a reply, that packet also should be changed, the header information, and then sent to the correct one who actually requested that packet, right? So there is processing in the proxy. So this is basically forward proxy. Right, and another thing that the proxy can do is, actually you can restrict to some sites. You can control that also, right? You can restrict clients going to certain sites. You can block, like these torrent sites and things like that, and maybe virus or other sites. Those can be blocked from the proxy server, right? So those things should be done, to make sure the internet is not misused, right? And it's available to all users in a fair way, right? So no one will misuse the internet resources, right? And waste, right? Yeah. So to avoid restrictions, to block content, protect identity online. Yeah, because the internet cannot directly see you, so it will protect your identity, right? Because it can only see the proxy server. Right. So reverse proxy, yeah, it sits in front of one or more web servers intercepting from the clients. It's like this. So forward proxy is actually on the client side. You can see, right, before the internet. So the reverse proxy is on the other side, right? So it's called reverse proxy because it does the reverse kind of thing here, right? So the forward proxy forwards client packets or information to the internet of servers. Then here reverse proxy, what it does is it actually takes the uh, client requests which are coming in, right? And then it will intercept and then it will forward to the servers, right? So there is no direct sending to the servers like this. So it will be through a proxy. So this direction is different, as you can see, right? Earlier, the direction was, coming in from the LAN side and then, or internal, coming in from the internal network and going out to the external or internet. Now here it is the other way, coming in from the internet or external and going out to the internal, right? So that is why it's called reverse proxy. Right. So here, the reverse proxy will actually forward it to the correct servers, right? So here, these servers are actually, you can say, hidden, right? Because you only send the traffic to the reverse proxy, and then reverse proxy will actually forward it to the servers, right? Now the actual server IPs cannot be seen, and no one can, directly communicate with these servers. So that is security, right? So you cannot attack a server if you don't know the IP of it, right? So you only know the IP of the proxy. So that is made publicly available. So these are the advantages. You can do load balancing, right? So that means if you have 3 or 4 servers, whatever the request coming in, so this proxy can send it to the server which has the lesser amount of load. Then protection from attacks, because this is what everyone can see, right? They cannot see the servers. They cannot see how many servers are there, where the servers are, what is the IP. Cannot see anything, right? So there's protection from attacks. Yeah. So then global server load balancing, yeah, it's the same thing, right? Yeah. So a website can be distributed on several servers around the globe, right? So actually this global server means you can have servers in a number of countries, right? Different countries. And then you can, so everyone will be communicating with the reverse proxy, right? So reverse proxy will decide based on the traffic where to send the that traffic, right? So let's say it's coming from Sri Lanka, right? Now, if they have a server in Sri Lanka, right? So it will forward it to that, right? Okay, then caching. So here also temporary storage is there to improve performance, right? So if accessing a site once, we'll have it in the reverse proxy cache, and then the second time, the reverse proxy doesn't have to contact the servers, and the server doesn't have to process that. The reverse proxy will send the cache page to the client, and so the bandwidth and the processing of the web server is also reduced. Yeah, then encryption. So that is to increase again the security. Okay, so that is basically the reverse proxy, right? So reverse proxy actually protects the server side by hiding the servers and so on. Forward proxy protects the client side, right? Hiding the clients and all that. So it can also provide protocol, port, and URL conversions. Right. So hope that forward and reverse proxy both are clear. Right. So we are going to the DNS or domain name system. So I told you earlier we have top level domain, then second level, third level, like that. Right. So here these are actually the top level domains. Right. APA, com, edu. So you must have seen this com, edu, net, and country wise. Right. So here we have .lk. Right. So in other countries also, UK, this is France, then US. So you must have seen some of those sites as well. They actually belong to the country, right? So these are actually global. These com or edu, it can be anywhere. These, com edu net. These which have the country code means that actually the servers are in that country. The domain belongs to the country. The server actually can be in the country or maybe hosted somewhere, but the domain or the owner of this, the URL, right? Let's say www.yahoo.us. So that actually belongs to US, the owner of that domain, right? So if you take these .com, the owner can be in anywhere, in any country. We cannot actually know who is the owner of that, right? This com, edu, or net. But country-wise domains, you actually know who the owner is, because only a person in the country will be able to get one of those domains. Right. Um, so these are second level domains, and then third level, and like that, right? Okay, so now we are going to talk a bit about DNS. So DNS is basically converting the name to an IP, right? For example, yahoo.com to the IP address. Okay, so you have recursive and iterative queries. DNS query means you send the name or URL, and then you request for the IP. So that is a DNS query, right? So DNS query means you send this name or URL to the DNS server, you get the IP as reply. Right, so DNS query you are sending to the DNS server. then you're getting the reply also from the DNS server. Right. So when you are sending the reply, so this DNS server is the closest to you, right? Not the you don't directly send to the original DNS or root DNS server. You will be sending to a DNS server which is closer to you, maybe in your country, right? So yeah, so the very closest or the first place of contact will be if you don't have a local DNS server, then it will be mostly your router or your gateway, right? You are sending the DNS query to your gateway. So your gateway will forward it to the internet service provider, right? So most probably internet service provider will have a local DNS server, right? For example, let's say SLT. So SLT will have a DNS server. So this will be sent to their DNS server, and in the server it will check if this entry is there, right? Or if there is a cache value of this. So if not, then it will be forwarded to another server, and then it keeps on forwarding through the DNS servers and eventually go to the root DNS server, right? So actually, yeah, so there are 13 root DNS servers. So one of those DNS servers should have this value, right? So when it goes to the correct DNS server, it will give a reply, and then that will come back to the client, right? So this is basically how the DNS happens. So recursive means you do the DNS query repeatedly, right? Maybe let's say if you have put up a domain server, right? So then there will be a DNS server also, right? In the domain server, or maybe a separate domain DNS server. Definitely you will have to have a DNS server if you are setting up a domain, right? So to find the servers, or maybe to find the clients, right? So each server and client is added to that DNS server, right? So from the name in the domain, you can actually find the DNS clients, right? So this recursive iterative means it keeps on searching locally, right, until it finds the correct device, right? Okay, then there are reverse zones, then yeah, reliability. So yeah, you can have backup DNS server, right, in case the primary fails, right? So that is what is meant here, master slave. Master is the primary one, then slave or secondary is the backup one. Then we have DNS negative caching. Then we have forwarding. Forwarding is so this query will be sent to the DNS server which is near to us. If it doesn't have this entry with the IP address, then it will be forwarded to another DNS server or the root DNS server, right? So that is actually how we configure the DNS, how the DNS server is configured, right? Then we have thing called the split. Okay, round trip time is the time taken from packet to go to the destination and then come back, right? Time required for a packet to travel from a specific source. Yeah, so let's say we are sending it, so we are the source, then to a specific destination. That means whoever, whatever the server which has this DNS entry, right? then that will give a reply. So the full time it takes to send to that DNS server or root server, then from the reply to come back, that is actually called the round trip time. Right? So I think I explained this round trip time, right? In the ping also, this is there. When I ping, so let me show you in the command prompt. So this round trip time, time to live, all these, yeah, these are there when you use the ping command, right? Okay, so when I ping to google.com, automatically IPs, the IP I get, this is through the DNS service, right? So it will contact the DNS server and get me the IP, right? And then ping to this IP, because you cannot ping to a name, you have to have an IP, right? So this reply is from the server actually, right? So we ping, send a ping request to this server, this IP. Then that server will give us a ping reply, or we call it echo. So echo request and echo reply. So the reply, this time shown here, this is actually the round trip time. That means the time it takes for the ping packet to go from here, my machine, to the Google server and then come back with the reply, right? That is the time shown here, round trip time. The TTL value or time to live is shown here. Now this round trip time, sometimes it might get delayed, especially if you are having wireless Wi-Fi. Okay, I have typing. Yeah, now do you see the round trip time is more, 265 milliseconds, right? This is 46. So yeah, the delay, so that means, maybe the distance to this server, right? So I cannot directly communicate with Yahoo or Google server, right? There are intermediate routers or nodes which I have to go through. So any delay in one of those intermediate nodes or routers will adapt to this round trip time increasing, right? So this will increase if there's a delay anywhere, right? Let's say I have a poor Wi-Fi signal, right? So then due to that also, this might delay. So in the internet, usually you can think that it's wired, right? So the internet, we can think of it basically, now we are pinging to the servers. So definitely it's a wired connection, but from my device to the router, it might be a Wi-Fi connection or wireless, right? So that delay also, if I have a weak signal, this will increase the round trip time, right? So there is a certain limit here, time. If this time is the amount goes high, so there's a limit actually where you ping and wait for the reply, right? So if this is delayed a lot, then actually you will get a timeout, right? So yeah, I cannot think of any site where I can get a timeout. So either my signal has to be weak, yeah, or the website, or the path should be slower. So yeah, these are the two round trip time and time to leave. So okay, so what is time to leave? So maximum value is 255. So that is the age of the packet, right? Okay, so yeah, let's take a break and come in 15 minutes. Okay, so I was explaining about TTL. Okay, so this is the lifetime of a packet. Why do we use this? Why do we need this TTL value? Can anyone tell me? Why do we need this TTL value, time to live, or why do we have to give a lifetime for the packet?
Because if we give the lifetime, there is some traffic increasing and truck is down. So we use TTL to expire our packet, and sometime packet are going to round by round. So if we set time to live, and we can destroy those which packets are not useless.
Right. So yeah. So actually, why this TTL use is yes. So we should make sure that unnecessary traffic or the packets should not unnecessarily stay in the network forever, right? So sometimes that can happen. So every packet has a destination, right? Source and destination, right? It has a source IP destination, source port, destination port, like that. It has some header data. So when a packet is forwarded to the routers, sometimes these packets sometimes can get lost, right? So we cannot uh, say that every packet will go to the destination. Sometimes due to some reasons, maybe the network suddenly disconnecting, or maybe an incorrect route from a router, right? So these sometimes the routers can have incorrect routes, right, at a time, at a certain time, right? So that can be due to various reasons. So maybe okay. Usually the router should not have an incorrect route, right? But many things can happen, right? Maybe a link can go down for some reason suddenly, so we cannot control those things, right? So things can happen, or maybe a device has failed, maybe a router or something has failed, and so a packet might not be able to go further, right? It might be lost somewhere due to a disconnection of a link or something, right? Maybe if there are no alternate links, it cannot maybe the packet cannot go or come back due to some reason, right? And then so it will stay there stuck forever, right? So we don't want that to happen. So if a lot of packets are getting stuck or yeah lost somewhere, right? So then that will increase, or yeah, if the number of that lost or packets increase, that will actually slow down the network, right? Because there be a lot of unwanted or unnecessary packets just looping here and there, right? Or there may be other reasons where let's say the source or destination IP proper details were not you know um, put in the packet in the first place, right? So if you put incorrect data or header data in the packets, right, the routers will just keep forwarding here and there, um, where there is no actual destination, right? let's say maybe let's say you send the packet from A to B, right? But then suddenly for some reason B goes offline, right? So B was online when sending the packet, but then due to some delay, the packet was already traveling in the network, and then B suddenly offline, not offline, right? Now where to send the packet? There's no destination now. So the routers will actually just keep on forwarding the packets until they reach the destination. So let's say B was offline for a long time. So the packet will keep on uh, circulating in the network or looping in the network, right? So so if the destination does not be online anymore, right? Let's say server or machine has it's the end of life of that server, and something has happened, maybe burnt or whatever, cannot put that online, right, anymore. So let's say we remove it from the network forever or something, right? But those packets, whatever, they will not be able to reach the destination. So due to these reasons, this TTL value is put to every packet. So every packet will definitely, if they don't reach the destination, will die at some time, right? Now the value we are giving to packets, we have to make sure that they live, that they will not expire before reaching the destination, right? For example, yeah, so let's think that, so this is the source and this is the destination. So we don't actually have an idea about the path which it is going through the internet, right? So maybe there can be one path, or usually there has to be. So internet is made up of a lot of networks. So you cannot say there's only one path available, right? So usually you should have more than one path to the destination. So I'm just drawing here one path, right? This is just one path. So in case one of these fail, so actually if you actually have if you have only one path like this, then if anywhere it fails, then the communication will not happen, right? Because if there's only one path available. So usually that will not be the case, right? So the internet, you definitely will find, you might find alternate or, redundant links like this. So, if any of one of the paths fails, so if one path fails, there should be another path. So redundancy is there so that, communication will not stop in case of failure of one of these paths, right? So there will always be an alternate, some kind of path available. So yeah. So when we are putting the TTL value, so we have to put the TTL value so that the packet will reach the actual destination before it expires, right? That means we should not put a very low TTL value. So putting a very low TTL value will make it expire before it reaches the destination. So TTL value is like this. Whatever the TTL value you put to the packet, right? Let's say, for example, you put TTL value 5. Um, yeah, so you are sending the packet from A to B. So if you put TTL 5, so if the path selected, you cannot decide, right? Usually it's dynamic and it changes according to the whatever the traffic or bandwidth, speed, those information, and it is decided by, so these are routers. So you cannot say, okay, this will definitely go in this path. You cannot say that, right? It will be decided dynamically at the time when you are actually sending the packets, right? So from here, there are two paths. So it will be decided based on how these routers are configured, right? The protocol which is used and the rules will be used based on the configuration of the routers, right? So some routers may decide on the shortest path, some may decide on a path which the bandwidth or speed is more and traffic is low, right? Less amount of traffic. So like that. So let's say now if this decides, now the packet is going from router to router. So the routers will decide path like this, right? Now this TTL value, whatever you put here, so starts from this A, right? Whenever it reaches another hop or intermediate this devices, routers or whatever, it actually reduces this amount by 1. So this we can think of as the maximum number of devices or hops that the packet will travel, right? So when it comes here, yeah, I better this I have to put here. So let's say I'm putting a low value, right? So when the packet comes here, it will be 4. So when it comes here, so per each intermediate node or device it finds, so they will actually reduce this TTL value of the packet by 1. So eventually, so this is done to make sure that the packet will die. So when it has come here, now the TTL is 1, right? So yeah, so actually when this receives the packet, so this means cannot send or forward this anymore, right? This is the expiry of the packet. So this router will actually discard this packet, right? So it will not be forwarded. This will not happen. Right? So this packet will actually be discarded when the TTL becomes 0. Right? So you have to make sure that the TTL value you use, so it should make sure that the packet lives in the network before reaching the destination. Right? So if it expires somewhere in the middle, then definitely that packet will be gone, right? So in this example. Now if you had a value of like 10, then that should be okay. But this is, I'm just simply drawing this with a few routers. So I don't know how many intermediate hops or nodes there are in the internet, right? Intermediate, and I cannot guess the path also, right? In which path, even if I knew the these routers and everything, I don't know which path it will take, right? So then I don't know how many devices or hops it will go through, right? So then I have to give a value so that the packet lives in the network before reaching the destination. So if I give a too low value, it will expire and never reach the destination, right? So if I give a higher value, let's say the maximum is 255. So if it reaches the correct destination, then there's no issue, right? But if it doesn't reach the destination, then we have a problem, right? Let's say we put 255, so it goes like this, and yeah, so suddenly when while that packet is traveling through these routers, right? Um, so let's say the packet is has come here now. So the packet is now here. So the only path to the destination is through this, right? So let's say, yeah, suddenly for some reason, this is not now not working. Now what will happen? So there is no destination to actually send the packet, right? So, and we have put a higher TTL value. So yeah, it will keep on circulating. So since there's no path here, it will maybe send again back to the path it came, or another path if there is, right? Let's say maybe there was a path like this, so it might send it to this again, right? So then this might send to this, and there may be sometimes a loop created, right? Because there are a lot of links. So if you put a very high value like 255, it will keep on going in a circle like this. So only one by one the TTL will reduce. So until all that 255 is reduced to 0, that packet will keep on looping, right? So that will actually waste the bandwidth and processing power of the devices or routers, right? So if you put a high value, those lost packets will keep on looping in the network, and then it will reduce some amount of bandwidth and also the processing power also of the devices, right? Because the routers or whatever the devices, they have to process that packet which currently doesn't have a destination, right? So yeah, you should put a TTL value which is not very low and not very high, but somewhere in the middle. So yeah, so these values are having some kind of middle value, so that it's not too high and not too low. So these should reach the destination without being expired, and if it doesn't reach the destination, then it will not keep looping for a long time, right? So maximum number of hosts it can go through is this value, hosts or devices. So that is basically TTL. Right. Right. Then we have this traceroute command. Anyone use the traceroute command?
Yes, sir.
Okay, so you have done that. Right. So this actually using this command, you can check the path that it flows, right? When you use the ping command. So let me CLS. Yeah, I sometimes mistake the commands for Linux and Windows. Right. Okay, so trace. I think trace RT. So I can trace the route to any server or any IP in the world, right? So yeah, actually it will only show up to maximum of 30 hops or intermediate devices. So this is the actual path which my packet is going through, right, when reaching the server. So first you can see my IP. These values are actually the round trip time, the time taken for the packet to reach, right? So the very first one is my router. So you can see the time is almost less than 1 millisecond, right? Because it is closer and there should be no delays, right? Then it would go through some SLT maybe servers, and then definitely it will go outside. So these are the intermediate nodes or routers or devices before actually reaching the my destination, right? Which is this IP 87 dot. So before reaching that, so I have to actually go through all of these intermediate devices, right? Now finally the 16th place I have my destination, right? So before reaching that, so there are 15 intermediate. If I take out my router, then 14, right? Yeah, so you can see the delays on each of these, right, when you are reaching. So this command actually, using this command, you can find out, let's say when you try to reach this destination, it doesn't work, it fails, right? So then you can use this command to check if one of the intermediate nodes has failed, right? What is the reason? So sometimes if it fails in the middle, then you will not get anything after that, right? So this will be different if you try to. Okay, it seems to be stuck. Okay. Yeah, so you see some of the IPs are repeating here. Yeah, I think up to this 222 it's the same, and then let's see, maybe it should be okay, it's the same IP again. 129, 133. Okay, 2206. Right, there I changed the IP. Yeah, so almost this has the same path then going outside. 125. Yeah, so this 166 was changed to 206. Then the completely different set of IPs here. Yeah, so if you are getting some same sort of IPs, then those will be definitely the service providers, some kind of intermediate routers or something, right? If they are going through the same IPs. So it's actually taking a long time for this. Okay, so anyway, you get how this works, right? It will go on until, so it will go up to a maximum of 30 hops, right? If If it goes more than 30, then it will not display. It will stop at 30, right? Okay, so what has happened here? I think it will go, okay. Yeah, if I'm getting a star, that means, yeah, see, so I am not getting a reply from these intermediate nodes or routers or whatever the devices, right? So there are some devices there, but yeah, maybe, this ping is blocked in those devices, so I don't get a reply. So what I will get is a timeout, right? Because this will wait for some time for the reply, and then if you don't get a reply, it will time out.
සර් ඒ කියන්නේ මේ අපන google.com එකේ routers ගන්න වැඩිනේ අතන Yahoo එකට වැඩිය එතන යන්නේ
Google
intermediate
එකේමද දන්නේ නැහැ. This is
නෑ
I'm
සර්
talking about intermediate. අතරමැදි
යන පාත් එකේ
ඔව්
අරකේ අපිට 16ක් නේ හම්බුනේ අර උඩ එකේ දැන් මේකේ මේ 16ට වැඩිනේ හැබැයි අර අපි ඉස්සෙල්ලා අර ping එකක් ගහලා බලද්දි අපේ මේ we can latency එක වැඩිම තිබ්බේ Yahoo එකේනේ. එතකොට සර් මේ routers වැඩි වෙලා මේ latency එක අඩු වෙන්නේ කොහොමද මේ Google මේක?
නෑ
routers ගන්න කියන්නේ.
ඇත්තටම මේ reply එකක් එන්නේ නැති හින්දා තමයි මේ වෙලා යන්නේ, because this displays the from each device it will display the latency. So
අර ඉස්සෙල්ලා මේ ping එකක් ගහද්දි අතන latency එක පෙන්වන්නේ මේ
ping කරද්දි total එකනේ එන්නේ. මෙතන ඔයා කියන්නේ එකතුව.
ඔව් එතන තියෙන routers ගාන 25ක් කියලා ගමුකෝ දැන්
එතන එතකොට directly server එකත් එක්ක එන latency එක තමයි පෙන්වන්නේ. මෙතනදී අපිට හරියටම කියන්න බෑ මේක එකතුව එකට සමාන වෙයි කියලා. මෙතන මේකට ping එකක් දාලා ඒ request reply එක එනකන් බලන් ඉන්න ඕනේ හැම එකටම. So yeah, there are set of devices which you definitely I think echo is blocked, right? That is why you don't get a reply. So the echo packet is blocked, or the echo reply is not sent. That is maybe blocked, right? So yeah, so you can see that is why it took a long time here. Although the latency you can see is small, but here time. Right. So yeah, so maximum up to 30. So this is 25. So it displayed all of it. But I think so they have put this maximum 30. Usually I think it does not exceed this 30 intermediate, the number of devices or hops. I think should be usually less than 30. That is why they have put a limit there. So you can see different servers. So they are located. Yeah. So this .com, we don't know where they are. Most probably they may both. I think should be in US, right? Their main servers, but we don't know. They can go some other country also. Yeah, actually using these IPs, we can check which country they belong to, right? Because these IPs are actually allocated to different. So usually this is managed by globally by one entity, right? Right. So this IP is in Ireland. right? And yeah, so see the ISP, Internet Service Providers, Yahoo, UK services. Yeah, and region, city, everything is there. So usually, these public IPs, they are allocated to certain countries and yeah, maybe cities. 100.216. Yeah, we are seeing some various different kinds of regions here. Okay, so anyway, yeah, see, so using the IP, we can actually know in which country it is, right? So this is Ireland, UK. Let's see this Google IP. Right, so that is in US. Right, so yeah, so US, so that is more far than UK, right? So yeah, so you know that what we see in the Traceroute, so according to the where it is located, right? And then so using this Traceroute, we are using the same ping sort of packets to the servers, right? So so those are called echo packets actually, and using the ICMP protocol.
noise
Sorry.
noise set
මොකක් හරි හිටපු ගමන් එදේ මොන හරි disturbance එකක් වගේ එනවා ඇත්තේ. Is it still there?
yes sir.
Okay. What sort of noise? Is it electrical noise?
Yes sir, yes.
Okay. Yeah, I'm not sure. Maybe due to some. Can you hear me?
Yes, sir.
Okay. I will continue then. I think maybe some. Okay. Do you hear the noise still?
No, sir, it's okay, sir.
Okay. Right. So this is the traceroute command, right? So by sometimes if you get now you can monitor through logs in our servers, right? If you are getting attacks or whatever, right? If you monitor the logs, event logs, it will show if someone is trying to log in to your server, right? If you have put it public, like let's say for domain server, right? So if there are a lot of logs which you have for someone trying to log in, then you might sometimes want to increase the security of your server. By looking at the logs, you can actually find out if someone is trying to hack or log into a computer or server, right? So because the IPs will be actually sometimes also in the logs saying, okay, this IP tried to connect, right? So you can actually find out who is actually trying to hack or trying to log in and from which country and so on, right? So that is because these IP addresses, because they are limited, they are managed by a single entity, the IANA, that is the organization which manages the IP address allocation, right? So there is a range given to our country also. So by having the IP address, we can check and we can actually find out to which country it belongs to, right? So these Microsoft servers and so on, when you are connecting, sometimes if you are using software to monitor, right, your network connectivity, yeah, let me show you. So, you can monitor the active connections using this netstat command also. And there are softwares which we can use to monitor the network traffic which is going outside, right? So if you have some communications or connections which you don't know of, then you can find out what those are. So they might be viruses which are installed on your computer and trying to connect with some servers, right? So some viruses may steal your username, password, or especially, yeah, there might be in your browser. So when you install this what do you call toolbars, right? So, you have to be careful. So some may have viruses in them, right? So what you type in your browser, like usernames and passwords, it might access and send somewhere, right? So yeah, when you are, sometimes you might not install the toolbar, but they are coming from small softwares. So you have to when you are installing softwares, right, don't just click next, because sometimes in the middle there may be some toolbars and things like that, and they have maybe added a tick to that also. You can, if you properly look into it, you can actually remove that tick and make sure that the toolbar is not installed. But by default, that's of, if you just click next, uh, by default they have actually selected those, right, to install the toolbars. So if you just run a setup in software and just click next, you might sometimes install those toolbars without knowing that they are there, right? So when you are installing, especially check when you are clicking next. In the middle, definitely sometimes they may have already, by default enabled installing some software. You might not even see those, right? Yeah, so here there are IPv6 connections also. I can see here. So this actually shows first the protocol TCP/IP protocol, then the IP, then you have the port. See the 65,000. Those numbers are ports which are established by maybe the browser or some software, right? So here the IP addresses which they are connected to. So this is my local IP port. Then I have the remote IP. So yeah, this established. So these should be, I think, browser. This HTTPS. So those should be browser connections. Whatever the websites I have loaded. Yeah, so established means already connected and communication is happening. Time wait means it's waiting for either to start the connection or stop the connection, right? And close wait means, okay, I think time wait is waiting for the to start the connection. Close wait is waiting to close the connection or disconnect, right? So yeah, these are the states of the TCP/IP, right, protocol. I told you, I think, earlier about. I think you know these things, right? The three-way handshake and everything. So after the three-way handshake, the connection will be established and then communication will happen. Right. So these are all the connections which are available. So, I can check these IPs and see where these are connecting to, right? So whether it's my browser or whether it's some software connecting to another server somewhere, right? So I can check actually using this. And, if there are viruses which are communicating with, let's say, some unwanted servers here, I can so actually identify and, because when you search for these IP, sometimes, in the internet, you get some, blogs or whatever explaining that these are actually used for, collecting your information maybe, right? So if they actually belong to some, Microsoft or with other types of servers, then you will see that. Otherwise, we'll see something else. Let's just see one of these IPs and see what sort of IP this is. Or where it's located. Okay, it's Singapore. Rubicon project. Yeah, so it's showing the ISP also. So might be related to software or some website you have opened in your browser. Right. So it actually shows you who the IP belongs to, right? Not only the country. So you can have an idea what this connection is, right? And then yeah, so you can then check if there's a virus in your computer. Sometimes let's say your computer is slow, right? And then you don't know why. So you can check the network connections like this, and then you can check the IPs and whatever. So which application is connected to the server and so on, right? Then you can know whether it's a virus or like that, right? Maybe some virus is using your computer as a what should I say, forwarder. That means someone is maybe forwarding files through your computer, right? So uploading to your computer, and then from your computer it goes somewhere. So then it will be using your network or internet bandwidth, right? So then definitely your internet will be slow. So sometimes these sort of things happen in the university also, right? So sometimes we get attacks from outside, and then they use our servers or whatever as to forward traffic, right? So because monitoring is happening, those sort of things can be identified, right? When a huge traffic is going through one IP, then using monitoring tools, we can identify, okay, there must be something going on here, right? Then we can actually, so we can block the IP temporarily, right? Until we find out what the problem is. Right. So back to the slides. So this Traceroute, yeah, when it reaches 0, then you get a time exceeded message, right? You get the reply. So this ICMP, that is the protocol being used for ping, traceroute, and various other things, right? ICMP, Internet Connection Messaging Protocol, right? So yeah, so sending from this to this side. Yeah, so you will get a message if the TTL expired in the middle, right? So time exceeded. So there are various diagnostic this kind of messages and various other things, right? Yeah, so sending to A. Yeah, so A will send the packet. So if it expired in the middle, then there will be a reply saying TTL expired, right, or time exceeded. Right, so this is the protocol used for ping and trace route and so on. So used by host routers, gateways, communicate network level information, right? So error reporting. So you sometimes get this kind of message: unreachable host, network port protocol, or you get a so echo request and reply. This is used by the ping command. Then these messages are carried also in so IP packets, right? This ICMP messages or packets are sent in IP packets. So yeah, ICMP, this these messages are embedded in the packets as a type and a code. So first 8 bytes of the IP datagram will be the error. So these are the types of errors and the codes, right? So this code will be sent with the ICMP packet if there is any kind of error, right? This kind of error, it will be sent in the packet through a code, not the description, right? So this is a standard. So there is a standard description for every code. Like if you take the computer BIOS, there is a for every beep or every let's say 1 beep, 2 beeps, 3 beeps, like that. So there is a description for that, right? It is shown to us as a sound. So that is one example. So here the error is actually given as a code or number. So we have to check this table and find out what is the error. So I think you may be familiar with these codes. Sometimes when you get error, maybe in a web page, right? Like the 403, or I think that's the code when you get when the web page is not displayed, right? Error code. So those error codes, they mean something, right? Those are standard codes. So those are actually used to exchange the errors, right? So then you have to actually get the description from the code. And in when you are using software or applications, sometimes even this Windows, Microsoft, right? You sometimes get a error code. So then you have to find what is that error code relating to that application. Maybe it's .NET um, .NET programming IDE, or some other kind of SQL, or any kind of application. They have their set of standard codes, error codes. So when there's an error, you can search and find out what. So it's because it's easy to just display the error code rather than displaying the actual error, right? It saves space in the it shows in a small dialog box in Windows, right? So easy to show the code rather than if the, let's say, the description is long, then there will be not enough space in those dialog box, right? So it's easy to display the code. So if you get any error code, then you can find it. So these are the error codes related to ICMP, echo reply. Yeah, so that means no error. If you get a reply when you ping or traceroute, so that means zero code is sent in the reply, right? Then yeah, so these are the other types of errors which you sometimes might get this destination network unreachable. Let's see if I can show you. Not this. Yeah, if I try to ping to some, let's say IP, which is, yeah, so there is, okay, it will give a timeout. So there is no IP like this in my network. Let's try something like this. Yeah, it's giving it a, okay, here is, it says destination host unreachable. Right, so it's trying in my local network. I think first one timeout because of a delay in my ping packets, I think, right? Then so I think, yeah, so the router will eventually find out if there is actually any device with this IP, right? So if it has, at least one time connected with the router, then it will have some kind of cache or history with it, right? So if there is nothing to be found, then it will say host unreachable. So either this is down, or either this host is down or it's not available, right? So like this, you get various kinds of errors. Yeah, right. Yeah, so the very first you get a timeout. So these IPs, there's no device available in my network, right? So destination host unreachable. So this code will be sent in the reply, right? Then so my command prompt, so it will actually read the error code and show the relevant description. So you might get, any of, so I think what I got it, destination host unreachable, right? Yeah, destination host unreachable. So sometimes you might get destination network unreachable if that network cannot be contacted. So in my case, I use my own network IP range. So yeah, so then it will show me as the destination host or the device is unreachable, right? So you might get these errors depending on the situation. Okay, so yeah, if it is a echo request, then you have this code. If it is a echo reply, then you have this code, right? So echo request is this packet is received by the destination, right? And the reply will be sent from the destination to the source, right? Then TTL expired, yeah. So that will, yeah. If you have a low TTL value, then if it expired in the middle, then you will get this error code in your reply, in the reply. Bad IP header. Yeah, so these happen according to the situation. Right. So that is about network services, right? Okay, any questions you want to ask about that?
Also clear, sir.
Okay, right. Right. So what is structured cabling? Any of you know about structured cabling?
Mm, how to connect servers,
How to?
how to connect servers and local area network.
Right. In a way, it's correct, but this is more than that. Anyone else? Have you heard about structured cabling? Just connecting server switches, that is part of this, but structured cabling, it has a vast area, right? About cabling. So it's not just this is not just related to just cabling, it's structured cabling. That means uh, putting the cables in a orderly manner, which we should be easy to maintain and all that, and the proper way, right? The proper standards, proper whatever code, yeah, the proper standards should be used, and yeah, physically also how you arrange the cables or take the cables here and there around, right? When you're laying the cables, cable laying. So all those things are actually within this name, right? For example, yeah, especially these fiber cables, right? Or optic fiber cables, right? So there is a way of how you if you take those fiber optic cables, right? You cannot put those cables like the copper cables, right? එහෙම අර නිකන් එහෙම අදින්න බෑ, right? The bends and everything, there is a way that we have to handle it properly, otherwise so if you have seen these fiber optic cables, they are very thin cables. Yeah, if you are using this nowadays in this newer smart TVs or audio video devices, or sometimes you get in monitors also, this audio out using the optic cable, right? So if you have used one of those, then you should know it's a very thin cable. You cannot bend it that much, right? If you bend it a lot, then it will break, right? So when you are fiber optic cables, especially when you are wiring them, right? So maybe you are taking them through a casing, or maybe you are just putting clips in your wall to hold the cables. So the bends, especially, you have to be careful. You can't have 90-degree bends in fiber cables, right? So it should be a round bend. Copper cables, not that much of an issue. You can have 90-degree, no issue. But those also, you should not bend them much, because it will not break, but the stress to the cable. So according to the quality of the cable, sometimes it might by time it will get damaged, or sometimes it might not work. So you have to keep those cables at a minimum stress level, right? So that is just one side I told you of structured cabling. There are many other things, right? So this structured cabling is creating an organized cabling system, right? Yeah, that can easily be understood by installers, network administrators, and any technicians that deal with cables. Yeah. So we are using some standards here, right? So using some maybe devices or tools, right? Right. Then rules for LAN. Look for a complete connectivity solution, plan for future growth, maintain freedom of choice in vendors. Yeah. So this has all the standards and planning methods and everything. This is like a total subject, right? So if you this can be network cabling, electrical cabling, whatever, right? This will relate to every type of cabling, right? So right, so look for a complete connectivity solution. So when you are going for a solution, so mainly let's say the network to connect devices, maybe servers, switches, right? Then maybe you need to go multi-story, right? That means, let's say you have 5 or 6 floors in the building. Like in your university also, you have like that, right? So then you have to have some kind of way to take the cables up and down through the floors, right? So you have to think how are you going to, take the cables or lay the cables so that, maybe the length of the cables you can keep to a minimum level, right? So that because there will be a cost factor also, right? And then having, network cabinets and things like that, right? So where are you going to keep those cabinets, right? And then when you are going floor to floor, you have to, connect those using uplinks, right? You have to connect floor to floor using basically uplinks, right? Cables. So then you might have to put, switches, right? Then or routers or yeah. So you have to decide. Then so this cabling, it might. So now here we are going to talk about networking, but this subject refers to every sort of cabling, right? So this network cabling, it can be the network of computers or any other, network devices, right? Maybe, if let's say phones or IP phones are used, then we have to think about those also, right? How we are, or let's say if you are having for the building cameras, CCTV, right? To the network or IP cameras, then you have to think of those also, right? And any other devices, network devices which you will be using in the flows, right? So you have to plan for future growth. So if you are upgrading, then so you have to think, right? So then will the structure of the network be compatible with the upgrades, right? Will you be easily be able to, let's say if you have more rooms or, you divide partitions, right? Then you may have to, if you are, putting up new labs, right? Maybe now you have only one lab, but later you plan to increase that number, right? Maybe in the same floor or different floors. So it's better to, think of those future plans when you are initially putting the cabling structure, right? Then it will be easy to, expand. Um, cost wise also it will be, easy if you, have a proper cabling plan. Then you might not have to spend more when you are expanding, right? The labs or rooms or whatever. Okay, so and then maintain freedom of choice in vendors. Yeah, so about talking about these vendors, so this means now if you are going for a vendor like, or let's say you are using you are going to Cisco devices, right? Network devices. So more so mostly if you are going with Cisco, then definitely you will have to have all the devices Cisco, right? If you are, to have proper kind of performance and everything. So then you will have to see, now Cisco is a brand, so that might, there may be several vendors who are dealing with the Cisco brand, right? So so why you have to think about this is, so let's say you are going with one vendor, right? Let's say a vendor called ABC, right? So we have come to an agreement, and then so that agreement will be for, maybe 1, 2 or 3 years, right? So we will come to agreement, okay, we will purchase only from you, right, within the agreement time, and according to, we might agree on some price ranges also, right? So then, right, so that vendor will then provide all the switches and routers or whatever, right? Camera. So everything that vendor will give to us according to the agreed, price range and whatever. Now the agreement will be for limited for some number of years, right? They won't usually have an agreement for a long time, right? So then after this agreement is over, like let's say after 3 years, then so then we might have to go for another new agreement. Then we might not get the same price and the same. So they will most probably they will want to increase, right, the cost and everything. So they will ask for the price and all. Definitely, they will go up, right, after some years. So they might give us they might not give us a lower price also, because they know that. So once we stick to one kind of vendor, then they will think that, okay, then if even if we increase the price, they will choose us as the vendor, right? So that sort of thing might happen. And sometimes if the cost is too high, we might have to stop the service with that vendor, right? Now then becomes the problem if we have to stop, right? Then so now we are going with this brand, right? So Cisco, as you know, so you will have to have the same kind brand of devices to be compatible, right? Usually you can mix other devices, but especially if you are using performance, if you are using Cisco standards, so some of them are they belong to Cisco devices only, right? They work with Cisco only. So then for compatibility, you will definitely have to new devices and everything, you will have to stick with that. So now what happens if you decide to stop with that vendor, right? Now we are in trouble. So then how are we going to buy the products and all that? So if there are other vendors also with the same brand, then we so there's a possibility for us to go with another vendor, so because we can buy the same brand, right? Now if there are no other vendors, and if there is only one vendor providing that brand, so so that will be a monopoly, right? Because only one person is handling that. Then sometimes we might have to we might be forced to go with that vendor again, even with the higher price, because we have no other choice, right? So this maintain freedom of choice is referring to that. So we should be able to choose which vendor we are going with. So if we are using some other brands, maybe HP or D-Link, or those we don't have much of a problem, because they are mostly those brands can be mixed, and they are compatible. You don't get a lot of compatibility issues with other brands. But if you are using especially Cisco, so it's better to use the same Cisco brand, because they have some additional kinds of these features and all that, right? Which if we start to use them, then definitely we cannot easily stop using them, right? Because once you get used to some kind of features or standards, then if we are stopping those, then we have to do a lot of changes. So you should be careful when especially going with that kind of brand, and then with the vendor, right? So this happens usually. So in case they decide to increase the price, and maybe for the maintenance also they might increase. That is usually what happens. Then we should be able to select, or we should have the freedom to choose the vendor. If that sort of thing happens, we should be able to go with another one, right? So you have to plan all this. So when you are starting, right, the network, so if you plan this, then you can go ahead, continue without any major problems. But otherwise, those things I said, they will definitely be a problem if you don't plan well, right? So even if you go with Cisco, and then let's say we use one vendor, they will say, okay, it's fine, we will keep on giving you service for a long time. They will say things, but if those whatever they say is not in paper, right, not in an agreement, then we cannot be sure that that will happen, right? So that is that. So you have to especially be careful of that actually happens, right? So sometimes even in universities, right, we buy a set of computers, then the next time we might not be able to buy it from the same vendor, right? So we will have to go to a different vendor. Then different models of computers means again maintenance, so those will be difficult, right? Different kinds of computers, different models, different drivers. So yeah, so we have to think those things also. Right. So yeah, this is the standard of cabling 568. We have A and B standard. So I think shown you before, right? So we have 8 wires in the Cat5 cable or RJ45 connector. So there are 2 types of standards we can use. This 568 A and B, right? The color coding will be different in each of the standards. Have I shown you the standards before? I think you know this, right? You know the color standards, right? For A and B.
Yes.
Yes, sir.
Okay, I will just show you just to remind you if you are. These are basic. So this is basically the 2 types of D568 color coding, right? So you have 8 wires in the Cat5 or network cable or UTP cable. So the order in which we use, right, in the connector is that is we have 2 types of standards, right? A standard T568A, it pin 1. So if you keep the connector this side, right, with the pins facing up or towards you, pins facing up. So the first or leftmost pin will be 1 and rightmost pin will be 8, right? So 568 8A standard starts with white, green, green like that. Then B standard starts with white, orange, orange like that. So actually, if you just compare these two, right, there's a change in 4 wires only. That is 1, 2, 3, and 6. Right, 1, 2, 3, and 6. The others, if you check these 4, 5, and 7, 8, they are the same. Right, same color code. So that is because usually this 100 standard, it uses only actually 4 wires, right? So the other 4 we called as reserved for future use, right? But now actually in gigabit Ethernet you are using those all the 8 wires, right? So this 100 Mbps speed actually uses only 4 wires. So 1, 2, 3, and 6, right? So their color codes are different in these standards because if you use a crossover cable, then yeah, so one side will be A and one side will be B, right? If you have a straight cable, then you have the same standard on both sides. So yeah, so if you have a crossover cable, right, usually used between the same type of network ports or devices, then you have to use the crossover. So the reason I think you know, right? Because so one side will be transmit and the other side will be receive, right? And since both devices are having the same pin configuration, right? Let's say PC to PC or router to router, right? Then you will have to mix these wires so that transmit will go to the see this white orange will go to 3 on the other side. So 3 will be receive. So this white green will go to 3 on the other side. So that is the receive, right? So sending signal should go to the receive signal of the other side. When ports or network ports are the same, right? If the devices are different types, like PC to router or PC to switch, then you have different types of ports, or the configuration is different, then actually you can use the same or straight through cable, right? So I think you know all these things. So this is the standard used in structured cabling. So TIA or EIA 568. So EIA stands for Electronic Industries Alliance. TIA stands for Telecommunication Industry Association. So these organizations have come up with this standard so that so I think why we use standards. So when we use standards in cabling and everything, you can use these actually anywhere, right? It's like using a language, like if so like using English language, so everyone knows that. So if you use that language, anyone can understand. So here also when you use the same kind of standard for every networking device or whatever, cables, devices, so you can take a switch or cable and you can go and plug anywhere and it will work. You don't have to worry anything because it's built according to the same standard, right? Right. So this standard makes recommendations for basic things like here: building entrance requirement, equipment room, then backbone cabling, horizontal cabling, work area. Right. So building entrance means so those are specifications for the point at which the cable enters the building. Yeah. So so there is a standard that you have to use when a cable enters the building, right? So how it should enter the building. Then include recommendations for the type of connecting and surge protection devices, right? So these recommendations and specifications are there for what is the type of connector or connection method that you have to use, and what are the surge protection devices that you have to use, right? Then also specifies placement of cabling used to connect the inside wiring to other buildings. Right. So this standard also has the information to how to place the cables which are used to connect the inside wiring to other buildings. So that means how the wiring should go out to other buildings, right? How that is yeah. So if I just draw in a simple diagram, so you have a building here. So inside we have some networks, right? So maybe you have another building here. So there are So there are standards as to, let's say this building needs to be connected to the other one. So how this, so the entry, building entrance, how this cable should be entered to the building, what type of connection we have to use, what type of cabling or media, what type of surge protection should be used here. Because especially when you are having this outdoor cabling, there might be issues with lightning, right? So usually internally you don't have that much of an issue because so the wiring is internal and the lightning affecting the internal wiring is much less. But outside or outdoor wiring, lightning might affect. Not only lightning, external, um, let's say there's a power line going near here. So that will affect this network wiring also, right? So things like that. So there are standards how it should enter, and specifies placement of cabling used to connect the inside wiring to other buildings. So there is also specification to how, sometimes, let's say one of these internal wirings, um, okay, you want to connect to another building, let's say, right? So how this should happen, the standards and everything, safety. So this contains the safety things as well, right? So especially when, you can't just have, wires hanging, especially, outside buildings, right? Ready well lage එහෙම තියන්න බෑ, right? Especially copper cables. Temporarily, you might have that, but there is a risk, especially lightning and things like that. If you just keep a cable hanging like this, if there's a lightning strike, then you have a problem, right? Because if that happens, it will actually go through the wires, and it can destroy everything which is connected, right? It will go maybe through to the switches, and then maybe to the computers or whatever, right? So it will be a huge damage, right? Yeah, so that is why there are standards to everything. So surge protection or something should be, you have to use if you are having cabling which has a high risk of lightning strike and so on, right? So
සර් අපිට මේ එනත්
yes.
සර් මේ අපිට ස්ට්‍රේට් ට්‍රූ කේබල් එකක් යූස් කරද්දි මේ TIA
ඒකේ ඕන
568 A
ස්ටෑන්ඩඩ් එකක් යූස්
වෙනුවට
කරන්න
B
පුළුවන්.
එක විතරක් යූස්
නෑ,
කරන්න
ඒක
බෑ.
ඕන එකක් යූස් කරන්න පුළුවන්, A or B.
හරි සර්.
It's better to let's say if you are maybe using wiring a house, or maybe let's say a organization or company or university, right? It's better if you can stick to one kind of standard like A or B, right? Because then it will be much easy for wiring. If you use both standards, right, for cabling, then you might have a problem. Usually, yeah, nowadays actually the having a straight through or cross is not a big issue, because the devices, the modern devices, they support any cable we use, right? So even if we use to connect PC to PC, we should use a crossover. But even if you use straight through, it will work, because now we have the technology, right? So actually there are protocols which will actually reverse, or if we connect PC to PC using straight cable, one of the network cards will actually change that pinout configuration through software, right? So that it will work. So even in switches also, switches routers, it is there. So we don't have to worry that much about this having straight to across through, right? But using these two standards, if we mix, right, in one place, sometimes when we are, in having new wiring or, changing the wiring, if we have the two standards mixed, then, it's difficult to maintain, right? Because sometimes some devices might not work, right? If we have this cross and straight through, right? So we don't know, that's better to stick with one standard, then it is easy, right? When you are, maybe let's say a wire gets damaged in the middle, right? Let's say a network wire gets damaged in the middle, right? So you have already done the wiring, right? Let's say you are using, so you have used actually B standard for this, right? So the connectors you have both sides. So actually you have used the B standard, right? Okay, sometimes, due to maintenance or anything, if especially these wires are, on the cable trays, which are kept on the top, right? Sometimes there may be damages, maybe due to maybe a mouse has eaten the wire, or right, maybe due to maintenance, those people have damaged the wire, right? So if something happens in the middle and it gets damaged, right? So then, yeah, so you have to actually then use two connectors to connect this in the middle, right? So if you are using one kind of standard everywhere, then not much of an issue, right? You just use the same standard here, and then it will work, right? Now, if you are using A and B mixed, right, and maybe earlier you have used the A standard to connect these both sides, right? In the middle, so if you mix up the standards, yeah, so sometimes things like this can also happen. Now let's say this got damaged and you put two connectors. So again, this might happen, right? So it got damaged somewhere else, and then again we have to put two connectors. Right now, you can see there are a lot of connectors between these two devices, right? So if you mix A and B in one of these places, the result, you might not be able to, predict like how it will come, right? So let's say you are using, initially you use the B standard, but then due to a damage, you use B standard again to connect these two. Then due to another damage, you use the A standard. Then, so there may be again another damage, and sometimes because usually you don't, because of a damage, you don't put the whole wire again, right? Usually you just put a connector and connect. So if you don't stick to one standard, you might be doing something like this, which might create problems, because now you don't know what kind of a cable this will be, right? If you mix up like this, so B here, it will change to A, and then again B, and right. So it's better to use one standard, then it is very easy for wiring. Even if it gets damaged, you can fix it and you don't have to worry about anything, right? Yeah, sometimes these repairs, later you might forget where these connectors are, right? And then you might not be able to troubleshoot a connection issue. So I'm saying this from experience because these sort of things happen, right? So even if you have casing, sometimes later, for maintenance, you might want to, um, maybe partition a room into two, or maybe break the partition or wall and then connect two rooms together, something like that. So things change, and these wirings, it's better if you can keep to one standard. Then if it gets damaged, you can easily repair and it will work, right? So if you mix up standards, sometimes you might, now in this case, you don't know what the result is, right? If you mix. So yeah, so due to that reason, it's better to have use one standard, right? Then it will be very easy. Okay, so these are things you get to know when you actually practically doing, right? Otherwise you might not think that mixing will be an issue. Okay, so right. So equipment room is typically existing telecommunications closet. It can be a secure storage area where, yeah. So we can keep these cables and connections, whatever racks or whatever, in a separate room, so that, yeah. So it can be a secure storage area, so that people cannot meddle, or people cannot access those things and change things or damage or whatever, right? So we can keep these in a separate room, because if, let's say, the maintenance people also, if they just damage, uh, so what I'm saying is not network maintenance, the other normal maintenance people, if they also can access the room, there might be issues if the network, these devices, right? If they do any damage, then it will affect all the people who are using the network, right? So if we have in a separate room locked, right, so only network people can access the room, so then that will be okay, right? So yeah, so if there is any damage, you have to replace, right? And then you have to, there is more cost to replace those equipment, right? So hardware devices like patch panels, hub switches, and routers. Yes. So it should be in a secure room locked, where only the required or necessary people can access the room, or it may be in a cabinet or whatever, right? Right. Locked equipment room helps prevent the theft of equipment and data security, right? So no one can steal, break into and steal if it is locked, right? And data security, yeah. So if the switches and things are open, someone can connect to it and maybe monitor the network, put a virus or something, right? So keeping it locked will prevent those kind of things, right? Right. So the standard recommends that the equipment room be located in the middle of the office space, if possible. Yeah. So why is it saying in the middle of the office space? So let's say this is the office. So the walls, right? So if we have equipment room in somewhere, yeah, let's say we can have it right in the middle, or one side to this side or this side. So that can be decided according to how we place the users, right? Like the tables or chairs which are arranged, right, in this area. So why we are having this in the middle is when we have in the middle, right, the cable length we can keep to a minimal kind of distance, both ways, right, like this. So if you have right in the middle, then you know, even if you are, you know, reaching somewhere here, so it's okay. But so it's sort of the same sort of distance to all corners if you're having like this, right? If you're having one in the middle of one side of the room, right, then you can actually reach these corners uh, at a shorter distance, but you know, the other corner, right, so it will be, there will be some kind of length if you are reaching the other corner, right? And so yeah, to reach here also, right? So same way this side. So right in the middle will be okay, but sometimes we might not be able to have a, you know, room in the middle, right? So maybe in a corner we can have one of these corners. So according to how you know, the chairs and tables come, we can arrange that, right? Yeah, so you know, if we are, you know, having this kind of arrangement, right, then we might, so this might be a good option, right? Minimum kind of length of the cables, because if we keep it here, then yeah, so you see the length will be more, right? So right, it depends, right? So yeah, so this way the cable that runs from the equipment room to the work areas can be approximate same length. So if you don't have in the middle and in a corner, right, so if you have in a corner like this, so then actually to reach this we have to, right, go here and here, right? So that will be long, right, the length. So in middle, if you have, you know, almost the same length to both sides. Yeah, so same time adhere to the maximum length standards. Yeah, so there is a maximum limit of when you this 100 Mbps can go up to 100 meters maximum, right? You can't actually use that maximum 100 meters. It will be less than that, because when it goes to that kind of length, the signal will drop, right? So you can't actually have one cable going that far. The signal will drop, right? We will have to have a switch or device in the middle, like a repeater, right? So if you have like in the middle, you know, you can keep the length short and it won't reach the limit, right? Okay, so yeah, this helps ensure reliable transmission of media. Yeah, if the length is more, you know, it might drop the signal, right? Or the signal quality might be low. So the less distance, the better, right? So definitely there will be a drop when signal travels very far in a cable. Backbone cabling is wiring that runs vertical between floors or between equipment rooms. So yeah, so backbone refers to the cables which interconnect maybe floors or buildings, right? These are high quality links, maybe fiber, right? Mostly used for the backbone cabling, right? So all the, you know, network and everything will be collected usually to the backbone. right? So it should have a proper structure and proper speed also, right? So it provides connection between equipment rooms and other building entrance site, right? So including cross connects, patch cords, terminators. So it can extend between buildings. Right. So when planning, it's good idea to double or even triple the length of backbone cable that is needed for installation. Yeah. So you can have additional links for backbone network, right? In case one gets damaged, you have an additional link available, right? Or if you have more links, then you can have more speed and bandwidth, right? And it's good in case one cable or path gets damaged, you can actually use another cable or path as backup. Right. This provides for expansion. That means if you increase the number of computers or connections, also if you have a lot of these cables for the backbone, then you have enough bandwidth, right? So you have to plan for the future. And the ability to run redundant connections. Yes. So that is what I said. In case one of the link gets damaged, you have extra. In the university also we have these fiber cables and all those things. We have actually redundant or extra connections, so that if one of the cables somehow get damaged, we can use a backup connection in that case, right? Right. When using copper for backbone, avoid sources of high-level electromagnetic or radio frequency interference. Yeah, if you are using copper cable for backbone, these high-speed links, right, between buildings and so on, and between floors, you have to avoid sources of this electromagnetic. That means power lines, high power lines, or any radio type of frequencies which are running nearby, right? Maybe antennas or that sort of powerful. If they are nearby, then you should not have the backbone cabling near to them, because that will give a interference for that signal, right? So then there will be interference for the network signal, which then will be a poor signal or poor quality signal, right, in the backbone. That is not good, because backbone means a place where a lot of traffic is happening, right? So you should make sure that it is free from any interference, especially if you are using copper wire, right? If you are using fiber, then no issue, because it doesn't, the electrical signals or electromagnetic interference is not affecting the fiber, right? Because it is using light. Right. So yeah, fiber optic, yeah, it's expensive, but it has advantages over copper. Yeah, since it can be locations such as elevator shaft, power lines. Yeah. So you can have them anywhere, even near power lines, because it does not affect from the electromagnetic interference, right? So lightning and things like that also we call EMI, right? So because of lightning also, this EMI effects will be there in the cables. So if you are using fiber, so it's lightning and any high power lines will be of no effect for these fiber cables. So backbone is stationary. Yeah, since backbone is stationary and there is less of it used, spending more money per unit length is, yeah. So backbone cabling will not change, right? Because they will be there for a long time. So it's like a one-time cost for you, right? Once you do the backbone cabling, then it's done. You don't have to, it won't change. So the price or cost spent will be worth, right? So fiber optic is the best choice for this background cabling. So usually between buildings, so where outdoor cabling is used, usually fiber cable is better option because less interference. You don't have to worry about power lines going nearby, right? Or lightning or thunder, right? Right. So recently the price of fiber optic was reduced, making this current backbone cable of choice. Yeah. So now many people are using this technology. So so this technology also is enhanced, right? And then the prices come down, right? So when a lot of people start using things, then the price will be down, right? Usually. Right. So this is backbone connecting equipment rooms. So places where the main cabling is there, right? For the maybe the floor or the room, or right. So connecting those sort of rooms, right? So we use backbone cable, right? Yeah. So this is the recommended backbone cable maximum distance limitation. So voice grade UTP 100 meter, sorry 800 meter, then STP grade 150 ohm 90 meter, then multimode, this is fiber. So this is 2 kilometer. So you see the using fiber, you can put the cable for a long length without using repeaters, right? If you are using copper cable, you cannot go this far, right? It's 100 meters. So if you are going more than 100 meters, then definitely in the middle you have to put switch or device as a repeater, right? Right. So patch cable is connecting from the switch to the device or switch to a router. So usually patch cable, this is the limitation given in the standard, right? So if you use more than that, then it will interfere with the signal quality and all that, right? So these are the limitations which you can use. Right. So horizontal cable is physical media that runs from the wall jack, the workstation to the termination in the equipment room. So this is one which comes from the wall jack, which is connecting to your computer or laptop, and going to the switch or the main switch room where all the switches connect, right? Right. So yeah, also includes the cable run from wall outlet to the workstation and the cable in the equipment closets that. Yeah. So anyway, this horizontal cable means the cabling which happens starting from your device or computer to the main network equipment room or closet. That has all the switches, routers, and everything, right? Right. So short pieces of cable are called as patch cords or patch cable. So there's a limit of 3 to 6 meters for that. So 3 meter limit from wall jack to the workstation. So that means there is a network port in your wall or floor, and from that you connect a small patch cable to your computer or laptop, right? The limit is 3 meters. So you should not use a longer cable than 3 meters. And 6 meters between equipment and the telecommunication closet. Right. So the recommended distance is 6 meter between the computer laptop to the main switch rack, right? Right. So usually this cable is put directly from the wiring main switch cabinet to your computer or laptop.
right? Without any joints. So if you have a direct cable, then you have a clean signal, right? So if you join in the middle by using connectors, so I think you know this, right? This is basic wiring. Even if you have electrical wiring, if you cut the wire in the middle and then have a join, that's not a good connection, right? Having a join in the middle. So if you have one wire, right, maybe let's say from your if it is electrical wire, then coming from your distribution board to a switch, or let's say a light bulb or wall power point, right? If you have one direct wire without any connections in the middle, then the electrical power can safely go without any problems. Like if you have joints in the middle, then definitely that the power or the signal, there will be issues due to because when there are connections in the middle, right, it doesn't properly the connection is not there, right? It doesn't sometimes properly touch the conductors, right? There may be loose connections. So if you have one single cable, so this is the case for electrical and network both, right? So in network cables also, if you have one signal, single one cable, and you have two connectors at both ends, that is better than having a joint in the middle, right? So having one cable and then two connectors. So this is better than having something like this, where you have some connectors in the middle also, because these connectors, they don't properly usually there's no proper, we cannot say that they will there is proper contact when we are using those connectors, right? So if the wire is continuous like this, electric or network, it can properly go through the conductor, right? Here when connectors are used, right, so sometimes they don't make proper contact, they might get corroded. So this is the same in every this sort of situation, right? Even let's say a motherboard, right, if you are installing a RAM card or PCI card, there again you have, so we have contact there, right? It's not so if it doesn't touch properly, or if it is corroded, right, the signal will not properly travel, right? But if you have some let's say your network is built into the motherboard, right? So you don't have a network card plugged in, but it's in the motherboard. That means internally, so the connection is there, right? So you won't have to worry about contacts, copper contacts, right? Which sometimes if they don't contact properly, the signal doesn't go. So that is what it says here. Right. So yeah, by not having those joints in the middle, there will be a proper signal, and yeah, and faulty connections and electrical noise will be reduced, right? Okay, so recommended that horizontal cabling is used, category 5 is used, right? But usually we use category 5E now. Yeah, so this is the maximum transmission speed. Category 3 will go, speed will be 600 megahertz, 5 will be 100. So distance is 100 meters, category 5, right? Then maximum 3 meters from wall jack to workstation. That means your wall port to your computer. This is the maximum length that is recommended. Then 6 meters from your computer to the main network wiring cabinet, right? Then 90 meters from the wiring cabinet. Right. Actually 6 meters in the telecommunication closet. Yeah, this 6 meters means actually this is talking about the cabinet, main network cabinet, right? Then 90 meters from telecommunication closer to the wall jack, right? So to the place, okay, so it's like this, right? So you have the network cabinet, then you have the wall jack, then you have your computer. So this should be maximum 3 meters. This should be maximum 90 meters, right? And then 6 meters they have said, so inside whatever the, yeah, so inside you have some wiring also, right? You have some switches and yeah, so the wiring you have here, so that, so they have mentioned as, that distance they have mentioned as 6 meters, right? So between your wall port to the main network, your closet, it should be 90 meters. Yeah, so okay, so yeah, it is shown here. So right, so you can see here, right, to the cabinet 90 meters and here inside 6 meters. So these are the required ones we have to use, right? So either 4 pair 100 ohm UTP unshielded twisted pair or 2 pair 150 ohm shielded twisted pair. So these are the recommended of fiber, this much, right, micrometer. These are the recommended ones for these type of cables, right? So usually you use UTP or yeah, fiber you don't usually use inside, but you can use, if you want, you can use. And STP also you don't usually use inside because it's very expensive. It's meant for outdoor cabling, right? Right. So you have to avoid any EMI, yeah, such as motors or heaters, wiring, air condition, metal beams, and walls. Right. So it can be put under carpets or in the ceiling, over beams, wiring trays, through firewalls. Right. So even as conduit back to the wiring closet. Yeah. So you can put inside conduit pipes also, right? Right. Cable length should be tested after installation and before equipment is attached. So you have to check the cable length. It should not exceed that amount, right? 100 meters. It should, yeah, actually the distance should be this, right? The limitations. So you have to check that before we actually connect your equipment, right? Right. So fiber optic cable, it has a long distance limitation of 2000 meters, like 2 kilometers, right? So I think 2 kilometers, yeah, 1 kilometer, 2 kilometer. That is a multi-mode fiber, right? Single mode, I think you can go more than that, but yes, okay. However, it is, yeah, fragile and expensive, and yeah, fragile means it can break, easily, and it's expensive than normal copper cables, right? So these are not fiber optic. This EMI is not affected, electromagnetic interference from high power lines or thunder, whatever, or these motors, or this air condition and things like that. They also emit this interference, right, which will affect the wiring. Right. So yeah, your work area will have computers, telephones, patch cables, adapters. So workstation will be connected to the wall outlet by patch cables like this, right? So this will be a wall outlet which will be near your computer. Right. So it is recommended that one wall jack and the second jack for UTP. One wall jack be for category 5 wiring and the second jack for UTP. Yeah, so you have to use the proper standard, right? When you are using the wall jack, means there is a female connector in the wall, right? Or keystone jack. So that should match with your wiring standard. If you are using Cat6 cables, then you have to get Cat6 RJ45 connectors and then Cat6 keystones. Then if they are connecting to patch panel, then you have to get Cat6 patch panel, right? So all of those equipment should match or be compatible with what the standard you are using. Otherwise, you will have problems. So if you are using Cat5, then you have to use Cat5 standard all things, right? So fiber optic is different from copper. So anything which you are using for the Cat5 cabling, so everything RJ45, keystone, then patch panel. So all of those should be Cat5 or higher, right? So it should not be lower. Right. So network plan for future expansion often has 6 outlets. Right. So you can have more, those wall ports, you can have extra. If you're planning for in future, let's say you might add new computers or devices, right? Then you will have to have more ports available to connect them, right? So cost, so you will have to spend some amount for those extra ports, but in future, that cost will be saved because you don't have to spend again for putting extra wiring, right? Right. So category 5 cable, yeah, you have to connect RJ45, 8 pin. Yeah, so this is if you are using STP, you have to use this sort of token ring connector, and fiber optic, this sort of connector. Yeah, so this is the RJ45 connector. This is a new connector. You can see the pins are all up, right? So this is the color standard. So A and B, right? So this is the color of the wire that should go to each of these pins according to the standard, right? Right. So this is basically how structured cabling happens. So from your wall outlet to the network cabinet, right? So we call that horizontal cabling. Then between floors, we call vertical cabling or connection of network cabinets. So the main network distribution of that flow, right? So yeah, we call that floor distributor or telecommunication closet. So it will be a room or a cabinet which is locked, right? Then those will be connected through floors like this, vertical cabling, right? At the bottom, so there will be the entry or exit point to the building, right? So we call that building distributor, or yeah, telecommunication, same sort of thing. But it, so the other cabinets or closets will connect to the other floors, but this will be your entry or exit point to the building, right? Then, yeah, so this is the building backbone, we can call it, right? Because it this is the connection to each floor, right? So building, we can call it backbone. So campus backbone, yeah, if this is a university, so then, you know, these will be connected to other buildings, right? So this, so it will be connected to this building, the backbone, right? And the other side will be connected to another building. So this building B we can consider as the main point where, you know, according to this diagram here, because every other, you know, building connects here, right? So according to this diagram with these three buildings, we can take this building B as the main point where, you know, it connects to all other net buildings, right? So you can see there's a separate cabinet for that, for connection of buildings, right? Yeah, so if you have some kind of antenna, then this is the antenna entrance, and this is how it goes through the floors. So this is the backbone pathway. Then horizontal cabling means cables which are going through the floors horizontally, right? So these between floors we call vertical. So yeah, there can be this telecommunication cabinets or closets can be like this at both sides, right? Right. So those are connected using this green connection, right? Then they are connecting to floors like this, and yeah, so you can have maybe a closet or a main point in the, you know, middle where, you know, everything in this building connects, right? And yes, so there's a, so this is the entrance to the building. Then there is internal wiring everywhere. Right, so it says here inter-building backbone. Yeah, so it should be connected to the vertical wiring, right? Okay, so this is where it enters the building actually. Okay, it says alternate entrance. Okay, there is actually a backup link, right? So you have two links which enter the building. One is the main link and the other one is the backup link. So in case one of these, the main one gets damaged, you can actually use the additional link to, you know, connect to the other buildings, right? Right, now all we have left is the assignment. So make sure you do that, and so I'm expecting a good one now since you have time, right? So you will be given marks according to how good you have your presentation and everything, right? Okay, so any questions from what I did today to be here, right? Okay, then if there are no questions, then we'll wind up for today. Then we will meet on the next Wednesday
Okay, sir.
for the assignments, right? So be ready, and so remember what I told you in the assignment. So please be ready, and the time also, you know, try to manage. Then, you know, we can quickly finish it, right?
Okay, sir.
Okay, then have a great week
Same to you, sir.
and stay safe.